talk about factoring trinomials. We started factoring yesterday and did factoring with the GCF. And today we're going to learn how to factor trinomials. We also did factor by grouping. Now, when do we do factor by grouping?
4 terms.
When you have 4 terms. Okay? So today we're going to learn what to do to factor when you have 3 terms. And those are called trinomials, right? 3-term polynomials are trinomials. All right, yeah, because I have it right there. Yeah. Okay. First thing you do before you factor anything is look for the GCF. Look and see if there's a GCF besides 1. So in this trinomial right here, is there a GCF besides 1? They all 3 don't have an X, so X is the GCF, and the leading coefficient is 1, which they're all going to be like this today. Okay, so if the leading coefficient is 1, that means the GCF for all your numbers is 1. Does that make sense? So, since the GCF is 1 and the leading term is 1, you're ready to make a table. Now, when I say make a table, it looks like a little chart. Okay? So, we want to make a table. It's a multiply and add column. Now, leave a little space after the word multiply. And my vertical line is very not straight. Okay? So, when you make your table, you're going to list a table of factors that multiply to get this number. Technically, 1 times this number, because that's what we're going to do for Monday. So, first times last, which is going to be 6. First, let me write this down. First times last. And then you're going to add to get your middle number, which is 5. So you kind of ignore the variables for a second when you're making your table. And you do want your trinomial in decreasing order as well. All right. So we want to list factors that multiply to give 6. So tell me 2 numbers that multiply to get 6. 2 times 3. What else? 1 times 6. Does anything else add to get 6? Nothing else multiplies to get 6, do they? Do either of those 2 numbers, when added together, make 5? 2 and 3 add to make 5, right? Cha-ching, put a check mark beside those. Those are my magic numbers. So you're going to take those 2 numbers, and you're going to make 2 binomials underneath your trinomial. They're both positive, right? X plus 2 times x plus 3. There's your factors. That's it. Now, I can check it with FOILing. Don't check it, but I'm going to check it. Don't you check it, because it'll confuse you, because you'll think you have to multiply, and you don't. I'm just going to show you why it works. Because if I multiply those back, I should get x squared plus 5x plus 6. So I'm going to FOIL it. X times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. Middle terms, x squared plus 5x plus 6. Yeah, it works. Okay. Yeah. So, what you do, you want to multiply to get your first times last number, which today is just going to be your last, because all of our first numbers are going to be 1s. Okay? Now, on Monday, that's the difference. The leading terms are not going to be 1s. Okay? So, Monday, it's going to get more complicated. Okay? But as long as our leading term is 1, you can just do the last number, and then you multiply to get that number, and you see which set of those factors add to get your middle term. And then you just write those 2 numbers in a binomial with x's in front.
And that's it?
Yeah.
It's always going to be plus?
No. Yes. Okay. Of course it's going to get harder than the first example. Hello. That's what makes it fun. Okay. So x squared plus 8x plus 15. What kind of polynomial is it? Trinomial. What's the GCF? It's 1. All terms don't have an x, and the leading term is a 1 for the number, so the GCF is 1. So it's a trinomial, which means we're going to make a what? Table. When I say we're going to make a table, if I don't see a table on your paper, that is not showing your work. Our work is our table, okay? No table, no credit. No credit, no good grade. Okay. So multiply to get first times last, which is what? 15. And you're going to add to get your middle number, which is what? 8. All right. That's disgusting. Raising the one. All right. So, what all multiplies to get 15? 3 times 5. And what else? 1 times 15. Does anything else multiply to get 15? Is there a set of numbers in there that add to get 8? 3 and 5. So we just make the two binomials, an x plus 3 and an x plus 5. And it doesn't matter which order you put the numbers in. As long as you keep the correct signs because they're both positive, it don't matter which binomial comes first. Okay? Because multiplication is commutative.
What you're saying is going to be.
Yeah? Obviously. Number 3. All right. So what's the GCF in this trinomial? 1. And I just said it was a trinomial. So we make a what? Table. So this time I want to multiply to get what number? 90. And add to get what number? 19. Now there's a lot of numbers or sets of numbers that multiply to get 90. I'll start you off. 1 times 90. Give me something else. 45 times 2. Okay. 3 times 30. 10 times 9. Yes, you do. 5 times what? What else? 6 times 15. And I think that's all I can think of. Are there any of those that add to get 19? 9 times 10. So what are my two binomials going to be? Yeah. And y'all looky here. What am I putting around my binomials here? If you don't have parentheses, that means it's not multiplication and it's wrong. Okay, so make sure you don't just write x plus 10, x plus 9 without parentheses. Okay, because it's mathematically incorrect if it don't have the parentheses. Is this terrible? Oh, I changed variables on us. Dang it. It's okay. So just make sure when you do your binomials, you do the correct variable for whatever's in the problem. Okay. All right. On this one, what's the GCF? 1. And it's a trinomial, so we make a table. Why do you think I keep asking that over and over? Because like on Tuesday, there will be every kind of polynomial all mixed together. So you got to know what to do. And if there's a GCF, you always would have to factor out your GCF first. Okay? So that's why I keep asking those, even though we got the same thing going on today. So we're going to multiply to get what number? 20. And add to get what number? 9. Here we go. 1 times 20. What else? 2 times 10. 4 times 5. Anything else multiply to get 20? Any of those add to get 9? 4 times 5. What variables go in front? These are n's. So an n times, or n plus 4 times an n plus 5 in either order.
Now, like, say we have the ones at number 3. Do we have to list every single, like?
List a couple.
It's like, I didn't know that 6 times 15. I didn't know that.
List a few. Okay, so like 72 is a number I can think of off the top of my head. 72, there's a lot of numbers that go into 72. A lot. Okay, so if you hit the right one off the bat, then just give me one more to go with it. Does that make sense? Now, obviously, if it's a prime number right here, you only got 1 times that number, right? Okay, so watch out. So obviously, if it's a prime number, then yeah, one set of factors would be fine. Does that make sense? But there's more than one, at least give me a couple. Okay? Here we go. I went a little big on you. Not too big. So a squared plus 62a plus 120. What's the GCF of this polynomial? 1. What kind of polynomial is it? Trinomial, so we have to make a table. So I want two numbers that multiply to get what number? 120. And add to get what number? 62. So I don't think it's going to be 1 times 120 because that's a lot bigger than 62. 2 times 60. Oh, there we go. Also 12 times 10, right? 3 times 40 and 4 times 30, right? There's quite a few. Do any of those add to get 62? 2 times 62. There you go. 2 times 60. Sorry. So what are my two binomials? Yeah, watch your variables. So a plus 2 and an a plus. Yeah, you got to be careful. I have to double check that every time. So make sure whatever your variable is you have is what you use. So y'all kind of see how this does. The work is in your table. I have to see your table on these, okay? All right, y'all try this one, and then we're going to do some negatives. Here's if you know your times tables. It doesn't hurt my feelings if you play with your calculator to see what all multiplies to get 84. You know it's even, so you know 2 goes into it, right? That's usually where I start if I don't have a clue, but I know my times table, so I know what goes into 84. Start with 2. 2 times what? 1 times 84. Everybody give me that one. Haley, check yours. 6 times 13 is not 84. Didn't you mark 6 times 13? I told you it didn't hurt my feelings if you used a calculator. Hmm? You got it. So, yeah, you got 2, so you're good. No. Yep. If there's more than 2, then just give me 2. That's fine. Yeah, if there's more than 2, just give 2. It's fine. You can have that. Not a ton, though. Well, it's 2 times 42. So anything that goes into 42 goes into it. So no 42 is 6 times 7. I believe 21 then goes into it 4 times. Right. I believe 14 goes into it.
By 6.
Yep. Yeah. Yeah. Y'all see that? Did y'all see my thought process there? Let me do my table. Multiply and add. So like I said, I know it's even. 84. Why did I skip it out so crazy? Whatever. So my thought process is this, okay? 1 times 84, obviously, and that is 2 times what? 42? Okay? So I'm like, okay, 42. I know 42 is 6 times 7, right? So that means anything that goes into these numbers will also go into 84. Okay? So I know 6 and 7 both go into it. And 14 does as well, right? So if it goes into 42, it's going to go into 84. Does that make sense? So sometimes cutting it in half and then breaking it down from that number will give you some more numbers that would go into 84. So that's kind of my thought process. And then if 6 goes into it, then 3 goes into it, right? Yeah. So there's kind of a lot of things there. So 84 times what is 6? Let me just fill in my stuff. 14. Oh, there's 14 already. Okay. And then 7 times what? Got a winner, right? Because 7 plus 12 is what? 19. So raise your hand if you got M plus 7 and M plus 12. Make sure you did M's. Any questions? But do y'all see kind of how my thought process? I divided it in half and then used that number. They deleted themselves. 6 times 14, 7 times 12. Whatever, touch screen. All right. So now, go ahead. You got to think a little bit more. All right, you got to think about your signs. So y'all write down number 6. We're going to start seeing negatives. So when we have negatives thrown in there in different places, we have to think a little bit differently in our table. So first of all, number 6, what's the GCF? 1. What kind of polynomial is it? Trinomial, so we make a what? A table. So I want 2 numbers that will multiply to get what number? 16. But add to get, that's negative 10. Now let's think for just a second about our signs. This is important. Okay? I want 2 numbers that multiply to be positive, but when I add them, they need to add to get a negative. Both negative. Because a negative times a negative equals a positive when I multiply, and a negative plus a negative, or a negative minus another number, or a negative minus a negative, or plus a negative is adds to get a negative. Does that make sense? Yeah, I know, but you gotta listen. Yeah. So for it to be positive here, they either have to be both positive or both negative, right? But a positive plus a positive is not going to get me a negative number. So that means they have to both be negative. Does that make sense? Okay. So I like to put my little 2 minus signs up there so I know that I'm going to list all negative numbers. Okay. So 16, negative 1, and negative 16. What else? Negative 2, negative 8, negative 4, negative 4. And that's all my factors of 16, right? Do any of those add to get negative 10? Negative 8 and negative 2. So when you write your binomial, you put minus signs in there. X minus 2 and an X minus 8. Okay? So whatever sign you have that works over here, that's what you need to put with those numbers in the binomials. So if it multiplies to be positive but adds to be negative, you're going to need both negative. Okay? Look at number 7. More negatives. All right, what's the GCF on number 7? 1. What kind of polynomial is it? Trinomial, so we make a. All right, I need more than 3 people answer me. It's trinomial, so we're going to make a table. So we're going to multiply to get what number? Negative 18. And we're going to add to get what number? Negative 7. Now let's think about our signs for just a second here. What kind of numbers multiply to be negative numbers? One of each, right? A negative times a positive. So I'm going to write a negative and a positive up top. I need one of each. Say that again, Jake.
Negative number will just have to be bigger.
He says the negative number has to be the bigger number. Why does the negative number have to be the bigger number?
Because it turns out to be.
Because the negative rules for adding is when you add 2 numbers, you keep the sign of the largest, right? So the bigger one needs to be negative. So I like to circle what the bigger one's supposed to be. Okay? So I need a negative times a positive because it has to equal a negative. And when they add together, they have to be negative. So the bigger of the two has to be negative. So when I list my factors, I'm going to list it with the bigger one negative. Okay? So for instance, I'm going to say negative 18 times positive 1. Give me another one. Negative 9, positive 2. There's one more. Negative 6 and positive 3. And I believe that's all my factors of 18. Now, which one of those add and make negative 9? I mean, negative 7, sorry. Negative 9, positive 2. Y'all see that? So we got to be careful when they start putting negatives in. So my binomials, 9 gets a minus sign and 2 gets a plus sign. Okay? No, you just got to think about it. If you know your sign rules, that's where all that comes from. All right. Everybody okay with that? How do we get good at this? Practice. Number 8. N squared plus 10n minus 24. N squared plus 10n minus 24. GCF is what? 1. What kind of polynomial is it? Trinomial. How do we factor a trinomial? Make a table. So I need two numbers that multiply to get negative 24 and add to get what numbers? Positive 10. So if I multiply to be negative, I need what kind of signs? One of each, right? A negative and a positive. And the bigger one this time is going to be what? Yeah, whatever this side, if you have one of each, whatever this sign is what your biggest sign needs to be. Does that make sense? All right, so I'm going to start bigger positive. So I'm going to start positive 24, negative 1. Positive 6, negative 4. Give me another one. Positive 8, negative 3, because I'm doing bigger positives this time. Positive 12, negative 2. Is that all that multiplies to get 24? I believe it is. Do any of those add to get positive 10? 12 and negative 2. So you got to watch your signs because if these were all positive, these would be it, right? Did that kind of catch your eye there? Okay, but yeah, when I add those, though, I get a 2, not 10. What are you confused about? Because when I add the two numbers, it has to be a positive. Sign rules for adding opposite signs. You subtract the numbers in your head, and the answer goes with the sign goes with whatever the bigger number was. All right. So these are n's. So 12 is positive. So n plus 12. 2 is negative. So n minus 2. We good? Y'all quiet on me. Some of you are. We okay? All right. Number 9. So now I'm just throwing them at you randomly with different signs in different places. See if y'all can hang on for the ride. Determine what to do with me. So on this one, we want two numbers. Sorry, I skipped ahead. GCF is 1. Trinomial, so we make a table. We're going to multiply to get and add to get negative 3. Let's talk about our signs. For multiplying to be negative, we need what kind of signs? Yeah, you got to have one of each. A negative times a positive equals a negative. But this time we're going to add to get what kind of number? A negative. So the biggest one needs to be what? A negative. The bigger one needs to be negative. Is everybody okay with that? Okay. So I'm going to start. Negative 18 times 1. Y'all give me another one. Bigger negative. Negative 6 and 3. Or negative 9 and 2. And I believe that's all. So any of those add to make negative 3. Oh, yeah. Y'all got that one quick. So that one is A. What's my binomials? Minus 6 and A plus 3. This is not terrible. We've done worse. We will do worse. We will do worse. Let's do this one. Square, because they are, this is like the most basic trinomial. We call this standard form of a quadratic, which we'll talk more about in the next unit when we deal with quadratics. Okay, so that's why. So the standard trinomial is a quadratic equation. So that's when you have a x squared term, and then the middle term is just an x, and then we have a constant. Yeah, so these are just basic. All right, so GCF is 1. It's a trinomial, so we make a table. I'm going to scoot up because 72 is one of my favorites. It's got lots of factors. Multiply to get 72 and add to get negative 17. Y'all tell me, what kind of signs do we need? Why both negatives?
Because they have that. Multiply to get a positive.
I don't know why I wrote that so small. But yeah, if this number is positive, that means they have to be both the same. So either 2 positives or 2 negatives. But since we're adding to be negative, we need 2 negatives. Does that make sense? Joseph, I'm teaching class this way. I told y'all how important this is. And if it's on my screen, it needs to be getting on your paper. Okay, so both negative. So -1 and negative 72 ain't going to get there close, is it?
-12 and -6.
-12 and -6.
-9 and -8.
-9, -8. -36 and -2. There's lots for 72.
-3 and -4.
24. So like I told you, 72 is one of those that have a ton of factors. There's a lot more, I think. I think 14 goes into it. No, not 14. 16 maybe? 4 does. Okay, so there's a lot of numbers that go into 72. Do we have one yet that adds to get negative 17? Oh yeah, so we'll stop. Okay, so if it's one of those numbers that has lots of factors, just give me a couple, okay? So y minus 9 and a y minus 8. You okay? One more. I think this is one of the deceiving ones. Yeah, it is. It's deceiving. Because I'm looking at it right now and I'm seeing 30 and 13. And I'm thinking 10 times 3. Anybody else think that?
I'm shaking my head now.
Okay. So make our table, multiply to get negative 30, add to get negative 13. Can I add? What kind of signs do we need?
Bigger negative and smaller.
Yep, I need one of each, and the biggest one needs to be negative. Y'all agree? So negative 30 times 1 is one set. What's another set? Negative 10 times 3. Negative 15 times 2, negative 6 and 5, and that's all, right? Do any of those add to get negative 13? Yeah, see, I'm telling you, my brain strength, when I say these two numbers, I'm 10 times 3, right? Because I know that adds to get 13, but since I have one of them's negative, one positive, that would add to get negative 7, which is not what I'm needing, right? So they throw those in there that are kind of tricky sometimes, that want you to just kind of glance and not do your work. So make sure you do your table. That's why we do it. All right, you guys are going to try some on your own. Actually, you're going to try 4. Boom. And then I got to show you a few little quick things, and then we're done. What's the middle term on number 13?
-1.
-1. There you go. Sorry, we didn't do one like that, so I want to make sure I told you. Check them with somebody when you're done, please.
I got A minus 35, A minus 2.
35 and 2. Okay, so I went ahead and set up my tables, and I just did M and A instead of mult and add because I was out of room. So number 12 is all positives, right? So when everything across is positive across your polynomial, you don't have to worry about your signs too much. So we want numbers that multiply to get 35 and add to get 12. 1 times 35 won't do it, but what does?
7 times 5.
7 times 5. Does that add to get 12? So raise your hand if you got an n plus 5 and an n plus 7 for number 1. Any questions? Number 2. Okay, I told you that middle term with the c is a -1. Did y'all see that? Yeah, so if it helps you, put a 1 there so you see it, whatever you need to do. So we're multiplying to get -30 and adding to get -1. What kind of signs do we need on number 13?
A negative big number and a small positive.
Yeah, a negative times a positive, because if this is negative, you need both, one of each. And this time it adds to be a -1, so the bigger one is the negative. So -30, +1. Something else? -10, +3. -6, +5. And just because I'm not a slacker, -15 and +2. There's all my factors. Couldn't say there just being one more, me not putting it in there. So what is any of those add to get -1? And what variables are these? C's, right? So parentheses, C minus 6 and a C plus 5. Raise your hand if you got a C minus 6 and a C plus 5 in either order. Good job. Number 14. I'm multiplying to be negative, so I need what kind of signs?
Small negative and big positive.
All right, negative and a positive. Then now the bigger one's going to be a positive. Yeah. All right. So bigger positive. So 22 -1 ain't going to work for me. What else is there? 11 and -2. Does that add to get 9? So what are the two binomials? And an x minus 2. Raise your hand if you got those two binomials on number 14. All right. And number 15. It's multiplying to be a positive, so that means I need the same thing, right? Two positives or two negatives. But if we add to be negative, we got to have what? Both negative. And it's not going to be -70 and -1. -2 and 35 adds to get -37. I mean, yeah. So a minus 35 and a minus 2. Raise your hand if you got those two for 15. Are there any questions about how we do this? All right. Now there's some little kink they throw in. I'll give you a couple examples of these and we'll be done. I promise. What's different about this trinomial?
It has another variable.
It has some more variables. All right, y'all see that? Has some more variables. So this is the a squared in the front and b squared in the back, right? And then it has them joined together in the middle. Y'all see that? So if you have, and the GCF is 1, because all three terms don't have an A, and all three terms don't have a B, right? So the GCF is still 1. So we count the terms. There's 3 of them. It's a trinomial, so we're going to make a table. Now, when we make our table, we're going to ignore our variables just like we've been doing. What's the last number without the variables? -15. And we're going to add to get the middle term, which is what? 2. What kind of signs do we need?
Negative and a positive.
And the bigger one's going to be a what?
Positive.
Positive. 15 times -1. What else, y'all?
5 and -3.
5 and -3. And nothing else multiplies to get 15, does it? Do either of those add to get +2? Okay. So the only difference, y'all, is when you write your parentheses, when you write your binomials, here's what you're going to do. You got a squared in the front, right? You break that down into a and a in the front, just like what we've been doing. Okay? But now we've got b squared in the back, so break the back terms into b and b. And then it was a positive 5 and a negative 3 that worked, so you just put those in the middle. A plus 5, oops, and a minus 3. So it's a plus 5b and a minus 3b. So that'll fix it. Okay, so just ignore the variables while you're doing your table, and then when you're finished, put your front variable squared in the front, your back variable squared in the back. Okay, that's it. All right, so your practice. This is practice time. Practice time. This is the end of class for today. Have a good one. Forgot to end my